for today. So today, this is the second session of the workshop on shopping with Graph. And this is about the hackathon that has kickstarted. Today, as speakers, we have McKenzie, Steenson, and Kristine Zheng to share a little bit about themselves. McKenzie Steenson is a developer advocate intern at Tigergraph, finishing her computer science degree at Boise State University. Beyond schoolwork, she has spent her time at Boise State cultivating communities within the school by creating club tennis on campus and leading the Artificial Intelligence Club. When she isn't working on exciting projects at Tigergraph or focused on schoolwork, she enjoys golfing and spending time with her friends and family. On the other hand, Kristine Zheng is a developer advocate intern in Tigergraph as well. And she's also a sophomore at MIT studying computer science and cognitive science. She's passionate about combining technology with research and is excited about the increasing use of graph technology in all fields. Outside of work and school, Kristine works in a neuroscience research lab and is a lead member in MIT Undergraduate Association student-run Banana Lounge, a study area with hundreds of free bananas. For fun, she loves solving crosswords, cooking, and traveling. So over to you, McKenzie and Kristine.
Thank you for that wonderful introduction. I'm going to go ahead and get my screen shared and the slides up. Can we see this okay?
Yep.
Perfect. On to you, Kristine.
Yeah, so I guess we just got a brief intro. I'm Kristine and I'm presenting with McKenzie. Next slide, please.
Oh yeah, my bad. I just mixed up the slide order since I'm sharing today, but anyway, sorry about that, Kristine. Just to touch base on what we had talked about at the beginning of our presentation on Tuesday, we're here to talk to you about graph databases and graph technology from Tigergraph. So again, if you've ever used social media like LinkedIn or Instagram, or if you've gotten really great recommendations from platforms like Google or Netflix, under the hood of all of these products and platforms is graph database technology. Graph databases are best utilized for highly connected data, and they're best applied to recommendation systems or other more complex machine learning applications. Tigergraph offers a flexible schema and high performance for complex transactions and deep analytics. So today, we'll be finishing building the full stack application that uses Tigergraph to interact with our data set and produce product recommendations to its users. And now on to Kristine. Sorry about that.
No worries. So what will we be building it with? We will be using Tigergraph's Graph Studio, Fast API, Flutter, and Firebase. Next slide, please. So just a review of our architecture. In the backend, we have Tigergraph, which is where we store our data, our graph, and our queries, and Firebase, where we store our images. For middleware, we have Fast API. So that's where we get our endpoints from Tigergraph to Flutter. And in the front end, we had Flutter, which is to build our web application. Next slide, please. Just a little overview of session 1 from Tuesday. We went over the data, so we have Amazon product reviews from data.world, which we cleaned, and then we built a schema and loaded the data and queries into Tigergraph Cloud. And finally, we began some of the environment setup, which we will finish today. On to you, McKenzie.
So in today's session, we'll be picking up where we left off on Tuesday. We'll be breaking down the middleware and how to get Fast API started as we utilize it for our endpoints from our Tigergraph queries. We'll then be getting into the dependency changes, the foundations and building blocks, the navigation portion, and then connecting all of that in our Flutter application with our Tigergraph endpoints. And to wrap up today, we will be initializing and implementing Firebase cloud storage so we can access our images for our application. And with that, we are going to start our demo today. So now we are headed to Tigergraph Cloud Studio. All right, take it away, Kristine.
Okay, yeah, so just a review from last time, we created a solution in TG Cloud. Some technical issues, but I hope you have loaded your data and looked at our queries online. So we have 3 queries. Here we will be looking at the schema. Here's the queries. So we will check if the product exists. Here we will check if the user exists, and then we will recommend products to a user given their ID. This will all be used, which you will see in the front end section. And we also have a Python loading script, which will be on our microsite in case you weren't able to finish this. And I think we were all set to move on. Next, we will start talking about the middleware. So there is an introduction on our microsite. Let me quickly put the link of the microsite here. So here McKenzie is starting to type the fast API section. So we will be importing typing and fast API, starting our app, and we can start making endpoints. So this will be an endpoint that says hello world. And next we will be using, she will be moving into the virtual environment, and we will be using UVcorn, which is a library which will help us show this on our local computer. Oh, you might have the tab already open.
Oh, that's right. That's right. Thank you for reminding me. You never know what can go wrong with these demonstrations. We'll try that one more time. Let's see.
I also have
here.
another one open, I think.
Oh my gosh, I do. All right, one more time. 3rd time's the charm. Interesting, interesting. Double check our Google Chrome tabs. And back to this one. So if you ever run into issues with running local pages within your terminal, something that I have to always look into and double check are which, I forgot the term for them, but which instances are running. So I need to look up real quick how to kill local host instances. How to kill a process. This is very interesting that this has happened. Well, in the meantime, because this is not wanting to run, we have a backup. So I'm just going to go ahead and get this video of what the correct output should happen in the meantime. So as Kristine mentioned, we're going to run the UVcorn main2 command to get that main2 file running. And when this loads, it'll populate with our 8,000 destination. And here we can see it populates with our hello world function that was returned. And so it's that we have an extra piece from Fast API that offers concise documentation. And then taking a look at our code for our the actual queries and endpoints that are created from our Tigergraph solution. We have configuration and credentials that are needed from our Tigergraph solution. And so when we implement these functions to call our user exists query, our product exists query, and our recommender functions or query, we're looking to gather the data as outputted from our Tigergraph solution. So we know that, for example, we're checking if the user exists with our user exists query. So we're just getting kind of a true or false results. But when we call our recommender query, it's a much different result from the input. And so with that, we're getting a list and getting our ID, the name, and the ratings of the recommended products from that query call. So in the meantime, I will also be sharing the backup that I created for this second piece. So we'll go ahead and get that started. As we can see, we're running this with the same command, just with that main. This second piece of the command is just the title of the file name. And so this one takes a little bit longer to load because it's connecting to our Tigergraph solution. So in the meantime, while that's loading, I have a really great joke I'd like you to answer, Kristine. What did the duck say when she bought lipstick?
I've never heard of this joke before.
Put it on my bill.
Oh, that's really good. That's really good.
You'll have that for your next party you go to make new friends, I guess. So now that this is loaded, we can see that we go to the docs aspect of Fast API, and we can, let's go back here real quick. I was too busy telling jokes. Within Fast API, it creates this clean and concise page where we can try and execute the endpoints that we just created. So here we can see that we can open up one of the endpoints. We can click try it out. It always stumps me. I always have to remember to hit try it out before I try to type anything in. And then here, we're asked to input one of the user IDs from our data. So for example, I know that Richard is one of the users and one of the product reviewers from our Amazon data set. And then we can go ahead and hit execute. And there we can see that Richard is true. So he is in fact in our data. And then they showcase if it's a successful response, if it was actually connected to Tigergraph. And then we can go ahead and check out our recommender query. So again, the input of this query that we created is a user ID, and then we're expecting to get a list of recommendations for those products and the information from our query. So we're typing in Richard one more time, and then we can see that in this response body, it's important to note for later in our workshop that the response is in a JSON format. And this response right here, this children and this list matches how we formatted it from our main.py file. So we have our ID, our name, our ratings. We can see here that matches with how we called it from this file. And so this is exactly also coincides with, I can get my Graph Studio open. Oh, that's just the screen recording. We get our Graph Studio open. You can see here, we click our recommender query. We want to type in Richard. It's the same output, and we can check our output in Graph Studio as the same JSON result. So this is really important here. When we can check our JSON result and see how this is formatted, this is very useful when calling this from Fast API. You know, for example, you can get very complicated with your queries and different hops and all the attributes that can be gathered from a recommender query or any other type of query. So it's really important that you're getting all the right information and that it matches from your attributes from Tigergraph. All right, sorry about those little hiccups there, but moving forward, we're going to go on and check out the Flutter build. All right, back into our code. And just another side note, we have all of our repositories linked within our slides, like Kristine mentioned. So this code can be found in the main repository. So following along with the microsite and the setup of Flutter, we'll be able to, if you follow along with the microsite, a Flutter app will be created and the project will be sitting next to in our main directory to our middleware folder. So here, this is where our configuration that connects from Tigergraph sits, that is connected in our main.py file. This is very important. Then we can go into our Flutter application and dive into the dependency changes for Flutter. So first, we need to go check out our pubspec.yaml file and understand what we're including as dependencies to get different pieces working within our Flutter application. So to make HTTP requests from Fast API in our Flutter application, we need to include the HTTP dependency. And another big one to note is our Firebase and our Firestore dependencies. And so once we finish up the setup for that at the end of this workshop, we'll be able to implement the Firebase storage. And these dependencies are what control all of that. So all of these dependencies, of course, are included in our microsite as well. So if you need to take a look at that after, please feel free. So now that our dependencies are set up, let's check out what makes a Flutter app run and kind of the foundations of a Flutter application. So our main Dart files reside in our lib file, library file within the TG Flutter directory. Then we can go ahead and check out our main.dart file. Our main.dart file, when you build an example Flutter application, will be the only file that resides in the library directory. And so this is what runs our app. It's like the main function of any Java application or Python application. So Flutter is, they consider Flutter and the UI of Flutter to be a widget tree. So most of what Flutter is built out of is widgets. So you can think of like this big widget that's built of separate containers within the widget. And so a few things to note that we'll take a look at after that reside in our main.dart file are initializing our Firebase storage, and then our application extending our stateless widget. So another big piece of widgets in Flutter is a widget itself is immutable. It isn't able to be interacted with or changed once the application is created. So to implement user input and user interaction, we have to use stateless widgets. And so stateless widgets enable that mutable states within Flutter applications. Moving forward, we need to now think about what our Flutter application needs to utilize all the queries that we wrote for our data. So we've got our user exist query, we have our product exist query, and we have our recommender query. So in my mind, I bucketed the queries, one for our user exists, and then another page for our recommender and our products exists. So that way in each page of our web application, we can check out different queries and they kind of make sense when they're on the same page. So this means we need to have navigation within our application. So within the library directory, I've created a new folder called pages. So this will obviously represent the different pages within our application. and then we can go ahead and check out our home page to see how we've implemented navigation within Flutter. So since we have multiple pages, we have created these files to match each other in a way that the states are all created the same. So in Flutter, we extend our stateful widgets, and then we create the state of each of our page. So this header and the beginning of each file all kind of match each other in the way that the states are created. Going back to our home page and checking out the navigation, a few important pieces are the page controllers and our bottom navigation bar. So our page controllers will control which page we're on. And so we can create an on-page changed function that can set the state of our Flutter application. So we can call an on-item tapped function when we're ready to change pages and change the index of our pages. And then within this home screen, we can implement our navigation bar. So we have an icon for our home page, we have an icon for our person page, and then we have an icon for our product page, which will be a shopping cart. Flutter is really, really cool that they have all these icons that you can kind of check out within Visual Studio Code. You can kind of preview. So there's my shopping cart. There's my little person. This is a home, obviously. And they have documentation that provides like thousands of icons that you can take a look through. So before I move on, I just want to ask, maybe Kristine, if you can look through the chat, are there any questions about how the navigation is implemented or anything before we go on to the next pieces? Okay, if not, then we will go ahead and change directories into our TG Flutter application. And then we will go ahead and run our app. So one important thing to note, if looking at my terminal here, is I'm using a different command here than the basic Flutter run command. And so this command, because Firebase has been implemented into my application already, I know we haven't talked about it yet, but Firebase, when you're initializing it into your application, it requires null safety to not happen essentially, because there can't not be anything when Firebase is created, and this command is a workaround that. So now we're going to launch our main.dart file, and this will automatically load a Chrome browser. Hey, Kristine, I have another joke for you.
Take it away.
So I like to practice magic. Last night, I was driving and I turned into a driveway.
What?
I turned into a driveway. It was magic.
Oh my gosh. Oh my gosh. That's
a bad joke. Okay, so now after we run that command and I tell bad jokes, we can see that this browser was loaded and we have our intro page. So we have a cute little GIF here of our tigers. Shout out those awesome tigers. We can see that navigation is implemented in our nav bar here. So we can click through the different pages that have been implemented below. So now let's check out another fundamental piece of Flutter and see how this GIF is being populated on our intro page. So we are going to move on to our intro page.dart file that again lives in our library directory. And this one's pretty simple. So we extend our stateful widget and we create the state of our intro page. And then we want to create a variable for our image path. And this was just a test. And then we want to create a Boolean to check if a button was pressed. Those are pretty simple. But the main piece of this page is our image network call. So our image.network function within Flutter takes in a string of an image, or in my case, a GIF from online. And so this was just something that I Googled, a tiger GIF, cutest one I could find, and that is what is populating on our main page. And so within Flutter, we can see a few of the main pieces. We created the title at the top of our page. So that's our intro page here. And then we create the body of our main page, which includes padding, basic padding around our image or our main piece of the page. And then so Flutter widgets can be contained as children. So a lot like HTML works. You can have children, containers, lists of all of these things. They can be listed in columns or any other available view that Flutter provides. And so this is just a simple box of cute baby tigers. Moving on from this Flutter basic, now we will check out our controllers and user input. So we're going to move on to our user page. So just to, since we got our Flutter app up and running, I'll leave this to the right here. Open up our Flutter app, and we will navigate to our user page. And this is when we start to implement our Tigergraph functionality. And so what's important to note here is our import statements. We want to get that http.dart dependency that we included at the beginning of the Flutter piece. So we can call those endpoints that were created with Fast API. So when we're utilizing the HTTP requests, it's important to create classes for the data we're receiving. So we've created a user class. And remember, what was returned from our Fast API user exists query was a true or false. So we're just going to call this success. It worked. And then another important piece is our factory. So this is what is getting the data from our JSON format and then returning that success variable. And so moving on, we have this basic Flutter fundamental of creating our stateful widget and setting the state. And then we want to create a couple controllers. So our controllers in Flutter are going to handle our user input. So we've created an ID controller to handle the user ID that is going to be inputted into our user ID input box. And then we have a couple helper variables to control some of the other strings. And then the next biggest piece of the puzzle when utilizing the HTTP requests is this right here. So we're going to call user exists. We're creating this function here, and it has this future tag in front of it to signify that it's going to happen in the future. It's not happening currently. It's going to happen when a user inputs the ID. It doesn't have to happen. It'll happen in the future. And this is an asynchronous call as well. Our URL, this is important to note from our Fast API, is going to be our Fast API URL for the user exists query call, the user exists endpoint. And we can see here, signified by this $, that this is going to be the variable or the string that we get from our ID controller. And then we go through a few more of the fundamentals for JSON responses within Flutter. We have to get our response by parsing the URL. And then we can return, if that status code was 200 from our JSON response, we can return the user information, which again is our Boolean success. And if not, we throw an exception. So if the response call didn't go through or it's not connected to Tigergraph for some reason, we'll get this exception thrown. So this is what's going on under the hood. And now how do we actually handle and receive that input into our page? So we have a couple containers here. Again, our page itself is a list of containers. This is the parent, and we have our children containers here. We have a basic container set for our user search. So that's our text right here. Then we have another container below that that handles our ID controller. So again, this controller is going to be handling that user input we just talked about. So, and we can see we have a little label, just kind of makes it look nicer there. Flutter is very seamless in a lot of its labeling and handling of text. So this next container is very important. This handles the logic of what happens with our user input. So containers have this child onPressed, which handles the onPress functionality of buttons. And so this logic right here, we have a simple print statement for testing purposes. But if this button is pressed, then we're able to set the state of our ID variable, which we created above, our string ID. When that button is pressed, we set the state of our ID variable to the text that we received in our ID controller. So again, this variable receives the input that's coming into our text box right here. So these two containers are controlling the functionality of receiving the input and then sending the input with our search button. Then the next piece of the puzzle is calling our user exists function. Before we call this user exists function, it's not even communicating with our endpoint yet. But once we call this user exists function, then we want to check the result of that. And our result was a Boolean, a success or not a success. So if that result was in fact a success, then we want to set the state of our ID string to the user input. Otherwise, we want to tell the user what you searched doesn't exist, maybe try again, and whatever you want to signify to the user to say, hey, this was incorrect. So now we can test out the functionality of this. We'll see if this works. We might have to restart our FAST API, but we can input Richard and search, and it is in fact connected to our FAST API endpoints by all miracles, and Richard does exist in our data set. But how do we know this wasn't just like a dummy hard-coded? Well, we can try my name. Oh, I'm not in the data set. We can try Kristine's name. She is also not in the data set. We can check Richard again. He is in fact there. We have a few other example IDs that you can check and play around with within these text boxes here. So before I move on, again, are there any questions about how this communicates with our JSON, with our endpoints, or what it took to build our states and populate our strings? Just send them in the chat, and Kristine, if there's anything I can help you answer, just please let me know.
Sounds good. I think no questions right now. Great job, McKenzie.
Thanks, Kristine. Okay, and now we want to move on to our product exists query. This is the main piece of the puzzle. So this is a little bit more complicated compared to our user exists query, because if we remember, our output from our recommender query was a list. And it was kind of a complicated list too. So our JSON response is handled differently within this piece. So again, we've got all our import statements in our product page. And then we need to create the class for our product. So again, if we remember what was in our query, we have an ID, we have a name, we have an image URL that becomes less and less important, but our ID and our name are very important. And so we want to handle these results from the JSON as strings. So that's how you would set up for a specific product. And then moving into the recommendation, we have our ID, our name, and then our ratings. And again, these are handled right here. And we return that recommendation class with our JSON responses. What's also different about handling a list within Flutter is it gets complicated because of complicated things I can't explain quite right now. But to handle some of the convolution within the JSON responses of lists, I've created a toString method here. So we can actually see, okay, we have our ID and the name of that product, we have our average rating, and we have our num rating. So we're going to call this toString method once we've handled the output and the JSON response within our widget. So here again is our basic foundations of a Flutter page. And then because this product page, again, remember, handles our product search and then our recommendation query, we have a lot more going on in terms of controllers and strings to handle our input and our output. So just taking a look at the recommendation query and the controllers for that, we create a text editing controller to touch base for that recommendation input. We have a few helper variables, and we have a helper function, right, or a helper Boolean right there. And then again, we have another asynchronous function to check if our product exists. And then we have our fetch recommendations function. So this again has to be able to handle that JSON list. So this is mapped into a list in a much different way than our basic user and product exists query. So we get our response and then we map it to the user class that we've created. So each output is mapped to each piece of our recommendation class here. Moving forward, it's all built in the same basic way that the previous page was with our controllers, our lists and children of controllers. And then moving down, we have our product recommendations. So it's all handled in the same way below as it was in the user exists query. And then we're able to test that here. So let's test out Richard, search him up, and we can see here that this was the same output that we got from our original TG Cloud solution. And again, in our fast API endpoint call. So we have Richard should be using the Amazon PowerFast official OEM USB charger, among other things. So to quickly wrap up, I do not have time to talk about the Firebase storage setup. This is all listed in the microsite, but I do want to touch base on the key points of its implementation. So one big piece of implementing Firebase into your solution is implementing the configuration within the index.html. So these configuration variables can be found within your Firebase console under the settings, and you need to be able to initialize your Firebase app there. So that is a piece of the basic setup, and then to actually get the information and the images that you stored in your Firebase storage, we want to go to our product page, and then we want to check out our product exists function. So here, what we want to have happen is when we input a product ID, we want the correct image to populate on the call and get the image from our Firebase storage. And so this is just a matter of handling the user input and the user controllers and going into our folders within our Firebase application and populating the page with this image. And so we have a few helper functions to get our image. And then we have this important image.network function that gets the data from our get image. So it's transforming from the user input, finding the product string, transforming it into a network call that gets the data from our Firebase storage. It's actively connecting to the storage that we've initialized. Another important piece of this, as we spoke of before, was including in our main function the initialization of our Firebase storage. So that is the last important piece of Firebase. So let's just check out. We have an example of our, let's see here. Let's check out this product right here. Go back to our Flutter application, populate our input and search. And this is just an image that was stored in our Firebase cloud storage. Firebase cloud storage is so useful when you don't want to muddy up your database, or you want to be able to store a lot of image or a lot of document store in a cloud service that's really easy to use and has a really straightforward setup and console for users to work with. Moving on, I think that wraps up the implementation and the main key points of building our Flutter application. So I'm going to get back to our slideshow. Kristine, I'm going to pass it on to you to talk a little bit about resources and next steps.
Sounds good. You did so good, McKenzie. That was wonderful.
Thanks, Kristine.
So here are some important resources you can review. So I sent out the slides earlier, but you can also view them again. So definitely, if you want to try out what McKenzie did, you can clone the repo from GitHub and import the solution. The microsite has a lot of instructions for this. And John asked, where do we go if we have questions? That's a great question. So definitely you can reach out to our Discord community or Tigergraph's community forum. And yes, Navera sent out the link just now. There's a ton of Tigergraph tutorials. There's some certification pathways. And definitely if you join our challenge, there will be a lot of support. If you reach out on your Women Who Code Slack channels, they can connect you with us. So definitely a lot of resources. And you can also connect with us via LinkedIn. So these slides will be sent out. And yeah, thank you, Stephanie.
Awesome. I'm going to touch base quickly on Google Developers Library. Once you finish building your project, you can try to use your own data set. You can personalize your queries and build your own solution in Tigergraph and implement Flutter and even Firebase in your own personal way for your own project. Once you finish that up, you can submit it to the Google development community through Google Dev Library and share it with developers all around the world to see what you've built and your exciting new project. So the links are also in the slides here as well. Just to throw another shout out to Tigergraph's $1 Million Challenge. If you weren't here on Tuesday, Tigergraph is hosting a Graph for All $1 Million Challenge for anyone from entry-level developers to PhD students to undergraduates, professors, any developer of any skill level to enter into the $1 Million Challenge. So at Tigergraph, we're utilizing this challenge to find impactful solutions, innovative solutions, ambitious solutions, and applicable graph solutions to major world issues, or making an impact in any way we can with our graph technology. We want to democratize graph and make it accessible for new users and existing users of Tigergraph. Again, it's applicable to startups, nonprofits, any sort of student, and any sort of developer. This is a virtual hackathon and it's hosted through DevHost. The hackathon has already begun and the submission deadline is 11:45. Don't wait until 11:59, 11:45 p.m. on April 20th. And the winners will be announced at the end of May. So to build your project, you'll pick a problem. Tigergraph has a list of problem statements you can take a look through and see if any speak to you, or build from a novel problem. You can build your project using Tigergraph and build a solution. Just as we built our solution on Tuesday, you're able to take your data and look into the connections of what you are focused on for your project. And then the last piece of the puzzle is submitting your project on April 20th. Declare your problem statement, submit a demo of your project, include the URL to give access for your GitHub repository, and then explain your project strengths to our judges. You could win the grand prize of $250,000, where the judging criteria, again, is based off the most impactful, most innovative, most ambitious, and most applicable solution. So if you are top marks in all 4 of those categories, you have a chance to win that $250,000 grand prize. One of the prizes that is very personal to me and I'm very excited about is our $30,000 Women Who Graph grand prize. So this was created with Women Who Code in mind. It's a play on words there, for a team of all women to submit a solution to be able to win $30,000 for their solution. We have other categories such as most popular, and then we have first, second, third places, first, second, and third grand prizes for each other judging category. We have lots of resources. You can check our weekly office hours. We've got lots of learning resources. So check out these on top of what Kristine and I have included in our master document. And then we have more you can access and have access to once you register for the challenge. Again, you can, if you'd like to check out the slides, we have a handy link you can click here. It's a massive orange button, you can't miss it. A few more quick links you can check out. And then if you have more questions, you can reach Navira, the organizer and the mastermind of the whole challenge. And again, reach out to our Discord community and our community forums. And with that, I thank you all, and Kristine and I thank you all for joining us today.
If you have any questions, definitely feel free to ask. Otherwise, we hope to see you with the challenge. It's been really great, these 2 sessions.
And thank you to Women Who Code for having us.
Yes.
It's been a pleasure.